These military machines are so strange and specialized and secretive that most people have never even heard of them, until now. Here's 15 military vehicles that you've probably never heard of. Starting with number 15, the RG33 Haga. Well, that's a catchy name, the RG33 Haga. Heavy Armored Ground Ambulance? Well, it's a variant of the RG33 mine-resistant, ambush-protected, the MRAP vehicle. They're designed specifically for medical evacuation in hostile environments. Developed by BAE Systems, the Haga represents a specialized adaptation of a platform originally intended for troop protection. While the base RG33 has seen considerable deployment and attention, the Haga configuration is much more obscure, and even military analysts are unaware of its role and field use. The original RG33 was based on the South African RG31 Nyala, which is a vehicle that's known for its mine-resistant qualities developed during the South American Border War. The RG33 improved on that lineage by incorporating a V-shaped monocoque hull that deflects blasts from improvised explosive devices. The 33L had extended length version of the vehicle. It supported more personnel and internal systems than the original, and the Haga variant builds on this longer frame to allow the space for 2 litters or stretchers, medical equipment, and attendants. The key advantage of this vehicle is its survivability and mobility under fire. In traditional conflicts, ambulances were either soft-skinned vehicles or modified commercial vans that offered little to no protection. This made casualty evacuation or case-vac missions extraordinarily dangerous, especially in areas with ongoing insurgent activity. And unlike larger, less maneuverable platforms, this one was nimble enough to navigate narrow urban streets while offering protection against small arms fire, IEDs, and artillery fragments. It was also equipped with a remotely operated weapons station, either a 50 cal machine gun or a 40mm grenade launcher. Despite the capabilities though, the Haga saw relatively limited use compared to the more generalized MRAP vehicles like the Max Pro or the Cougar. The vehicle was mainly issued to specialized Army medical evac units and some Marine Corps units during the later years of the Iraq and Afghanistan conflicts. Today, with the drawdown of large-scale operations in the Middle East, many RG33 variants, including the Haga, have been phased out. The medical evac role in modern doctrine is increasingly being shifted towards rotary wing aircraft or upgraded armored personnel carriers. Still though, the Haga has a unique place in the evolution of combat medicine. It marked a moment when the battlefield survival wasn't only about firepower, but about safely extracting the wounded from the kill zone. Number 14, the Sea Slice. The Sea Slice, that's such a cool name, was an experimental U.S. Navy ship developed in the late 1990s to test unconventional hull designs for improved speed, stability, and stealth. It was designed by Lockheed Martin. The Sea Slice was a small waterplane area twin hull, or swath vessel. But with a radical twist, instead of 2 submerged hulls, it had 4 arranged in semi-diagonal X configurations. This unique shape gave the vessel both its name and its unprecedented seakeeping abilities. The Sea Slice was an evolution of earlier swath concepts, which were designed to minimize the effects of waves on a ship's motion by placing the bulk of the vessel's displacement under the water. This reduces the surface area affected by waves, resulting in a smoother ride. Sea Slice pushed the concept further by introducing double pairs of submerged hulls connected by narrow struts to a flat upper deck. The ship was about 105 feet long with a beam of nearly 55 feet, and it displaced around 180 tons. The design allowed for a large, stable deck area, theoretically ideal for mounting weapons, launching unmanned systems, or conducting surveillance. It was never armed, nor was it intended to enter active combat service. Instead, it functioned purely as a test platform, evaluating new naval technology for future fast attack craft or coastal patrol vessels. The ship's high speed, capable of over 30 knots, and low radar profile generated some interest, particularly as the Navy was exploring new combat ship designs, LCS, littoral combat ships. However, Sea Slice was ultimately not selected for follow-on production. Furthermore, competing technologies and shifting Navy priorities pushed the concept into obscurity. In 2011, the vessel was purchased by a private company called Advanced Offshore Solutions. They intended to convert it for offshore wind farm support work. The company modified the ship for commercial tasks like crew transport and equipment hauling in the European waters, and for a time, it operated out of the UK under a civilian flag. However, the transition to civilian life was pretty short-lived. Maintenance and operational costs proved pretty high, and the ship was laid up by the mid-2010s. In 2016, Sea Slice was spotted deteriorating in a dock in Cuxhaven, Germany. By 2019, the vessel was stripped and scrapped. Its legacy, though, lives on in naval architecture, where swath designs and unconventional hull forms continue to inform fast, stable platforms for surveillance, research, and special ops. Number 13, the PZL M15 Belfagore. Another mouthful of a name, the PZL M15 Belfagore. It holds the unusual distinction of being the world's only jet-powered biplane, and the only jet aircraft ever mass-produced for agricultural purpose. Developed in the 1970s by Poland's aviation plant under the Warsaw Pact, this strange aircraft was created not for combat, but for state-of-the-art agricultural spraying over Soviet collective farms. However, its story intersects directly with Cold War-era military logistics. The M15 was developed in response to a Soviet directive to replace aging Antonov AN-2 biplanes used for crop dusting and other agricultural roles. The idea was to modernize the agricultural air fleet with a more durable, efficient jet aircraft. The M15 retained a biplane configuration with two large wings stacked vertically. That was a design choice that was already obsolete by the 1950s. However, it incorporated a single turbojet engine mounted in the fuselage above the cockpit, producing about 3,000 pounds of thrust. The aircraft was constructed primarily from metal and featured a pressurized cockpit and had twin booms leading to high-mounted tailplane. The fuel tanks and chemical spraying systems were placed in the large wing root fairings, giving it a bulky, squared-off profile. From a distance, it did look like a propeller-driven crop duster until you noticed the absence of any propellers and the presence of a large jet intake. Performance-wise, the M15 was underwhelming. It had a maximum speed of around 200 kilometers an hour, that's about 124 miles an hour, a payload capacity of about 1,500 liters of chemicals, and a ferry range of about 400 kilometers or 250 miles. It was sluggish in flight, noisy, and highly fuel inefficient, burning kerosene at a rate far higher than the AN-2s it was meant to replace. It earned the nickname Belfagore from factory workers. That's a reference to a demon from mythology due to the high-pitched whine of its jet engines and its awkward, haunting appearance. The name stuck unofficially and eventually became synonymous with the aircraft. Despite the considerable investment in its development, only about 175 units were built between 1976 and 1981, mostly delivered to Soviet bloc countries. By the early 1980s, the program was scrapped. The AN-2 did continue to serve for decades afterwards, as the M15 simply couldn't compete with its cheaper, simpler, and far more effective piston-powered predecessor. Aviation historians regard the Belfagore as a fascinating case study in design by directive. It's a reminder of how even the most bizarre ideas can make it to mass production under centralized planning. Number 12, the Visel AWC. Hey, look at that, a normally named thing. The Visel Armored Weapons Carrier, the AWC, is a uniquely small-tracked military vehicle developed by Rheinmetall for the German Bundeswehr, the armed forces. Designed during the Cold War for rapid deployment with airborne troops, the Visel is both diminutive and specialized, so much so that it largely remains unknown outside of military circles despite its decades-long service history. First introduced in the 1980s, the Visel, which translates to mean weasel in German, was created in response to the German Army's requirement for an air-transportable armored vehicle that could accompany paratroopers into combat zones. The result was a vehicle that weighed less than 3 tons, was only 1.8 meters tall, and measured just 3.5 meters in length. Despite the small dimensions, though, it offered armored protection and could be configured for a wide variety of roles. There are two main variants, the Visel 1 and the Visel 2. The 1 was introduced with weapons options, including a 20mm Rheinmetall autocannon or a TOW anti-tank missile launcher. The weapon's compact chassis made it ideal for ambush tactics in urban combat where mobility and speed were more important than heavy armor. Its low silhouette allowed it to hide easily in terrain and behind cover, and its fully tracked drivetrain enabled it to travel over soft ground and rough landscapes. The Visel 2's later development, in a stretched version that included enhancements in payload, armor, and versatility, and variants of the two included reconnaissance models, command and control vehicles, mortar carriers, and even air defense units equipped with Stinger missiles or radar systems. All versions, though, retained the Visel's core attributes: lightweight, transportability, and multi-role adaptability. One of its greatest technical advantages is the compatibility with the CH-53 and CH-47 helicopters, as well as the C-130 and A-400M transport craft. A single CH-53 can carry a Visel slung beneath it or internally with some variants. This air mobility means that German paratroopers can be dropped into an area with immediate fire support, dramatically increasing their survival rates. The Visel has seen deployment in several overseas operations, including peacekeeping missions in Kosovo and Afghanistan, where its lightweight design proved useful. It's never been widely exported, though, with only a few units going to countries like the US for testing or evaluation. Nevertheless, within the German military, the Visel has maintained a consistent presence. As of the 2020s, the Bundeswehr continues to field Visel vehicles, particularly in airborne and mountain infantry units. In an era that's dominated by large, heavily armored vehicles, the Visel remains a curious counterpoint, a compact, agile, and purpose-built machine that fills a very specific tactical role. Its obscurity may stem from its low profile and limited export, but among those who know battlefield logistics and tactical mobility, the Visel AWC is considered a remarkable piece of engineering. Number 11. The Myasishchev M17. During the late Cold War, the Soviet Union quietly developed a little-known high-altitude reconnaissance craft to rival the capabilities of the American Lockheed U-2. The result was the Myasishchev M17 Stratos, a single-engine jet aircraft designed to operate at the edge of space for surveillance. Its shape, niche role, and extremely limited production have made it one of the most obscure aircraft ever flown in Soviet service. It originated in the 1970s under the Myasishchev Design Bureau, which had previously built Soviet strategic bombers. It was conceived as a high-altitude platform for intercepting American reconnaissance balloons that drifted over Soviet territory. It was intended to operate at altitudes above 21,000 meters, that's about 69,000 feet, just beneath the operational ceiling of the US U-2. Its design is immediately recognizable. It featured an extremely long wingspan, over 37 meters or 121 feet. It's reminiscent of a glider or a sailplane. Its single engine was mounted on top of the fuselage in a dorsal nacelle. That's a rare configuration that kept exhaust heat away from sensitive sensors that allowed better airflow at high altitudes. The cockpit was pressurized, of course, and sealed for extreme altitudes. Pilots wore full pressure suits, similar to those used in space programs. And though it was unarmed, it did play a strategic military role, operating above enemy radar. It was first flown in 1978 and had very limited production. Fewer than 5 airframes were even built, and only 2 were known to have flown operational missions. Nevertheless, it proved capable of reaching over 70,000 feet, and in 1993, after the collapse of the Soviet Union, a modified M17 set a world altitude record for a Class C-1E jet aircraft, 21,830 meters, that's 71,585 feet. It also set a record for a horizontal flight at that altitude, making it a rare Soviet counterpart to US high flyers. A successor aircraft, the M55 Geophysica, was developed with twin engines and improved capabilities, but it too remained obscure and was used mostly for scientific missions, including work with the European Space Agency. Today, the surviving M17s and 55s are preserved in Russian aviation museums. Number 10. The Zuber Class LCAC. The Landing Craft Air Cushion, or the LCAC Zuber Class, is the largest military hovercraft ever built. Known as Project 12322 in Soviet nomenclature, this assault landing craft is capable of delivering armored vehicles, troops, and equipment. Despite the massive size and appearance, the Zuber class remains largely unknown outside of naval circles. It was first developed in the 1980s, and it was created to support Soviet amphibious assaults. Unlike strategic landing ships which require ports or well-prepared shorelines, the Zuber was designed to launch from the sea, skim across the water at about 60 knots, that's 111 kilometers an hour, and drive directly onto a beach, even if the terrain was soft, muddy, or mined. It's powered by 5 gas turbines, 2 for propulsion and 3 for lifting air. It rides on a full cushion of air held in place by flexible skirts, allowing it to float above water, ice, or even land. At full speed, the noise of this thing is deafening. The cushion of air can scatter debris and sand over a huge area, which is effectively non-lethal but intimidating psychological weapon. It's over 57 meters long or 187 feet, and it displaces about 550 tons, making it the heaviest hovercraft in military service. It can carry 3 main battle tanks or 10 armored vehicles along with 140 fully equipped troops. It features 2 30mm AK-630 close-in weapon systems that CIWS for defense against incoming missiles, as well as rocket launchers and surface-to-air missiles. Its self-defense suite makes it far more survivable than traditional LCACs used by Western navies. Only about 10 of them were ever completed, and they were originally built by the Soviet Union and later by Ukraine and China. After the USSR dissolved, several were inherited by the Russian and Ukrainian navies, and in the early 2000s, Ukraine built 2 additional Zubers for export to China. Greece also operated 2 of them acquired from Russia in the 2000s, but maintenance and cost challenges made them difficult to sustain. Today, they remain operational in Russia, China, and possibly still Greece, though the numbers are small. Still though, its unmatched payload capacity and raw power has never been surpassed in the world of hovercraft. Number 9. The Rattel Infantry Fighting Vehicle. The Rattel Infantry Fighting Vehicle, or IFV, was a development and military vehicle design that was pretty pioneering, created during the 1970s by South Africa under conditions of global arms embargo and regional warfare. It was one of the first wheeled IFVs ever built, predating the widespread adoption of these vehicles by NATO countries. Developed by Sandock Austral, now Denel Land Systems, the Rattel was born out of necessity. During the South African Border War, 1966-89, the South African Defense Force needed a vehicle that could carry infantry, support mechanized ops, and survive long-range desert warfare. Traditional tracked vehicles like the Soviet BMP series was heavy, difficult to maintain, and ill-suited for the rugged terrain of Namibia and Angola. A new solution was needed, something faster, lighter, and easier to repair in the field. The result was the Rattel, a 6x6 wheeled IFV with a distinctive slope design and a modular turret option. Weighing around 19 tons, it was powered by a diesel engine capable of speeds of 105 kilometers an hour, that's about 65 miles an hour. And its operational range exceeded about 1,000 kilometers, making it ideal for long-distance patrols required in the South Africa far-flung operational theaters. It featured a 20mm autocannon that was suitable for infantry support and light vehicle engagements. It was equipped with a 90mm low recoil gun, giving it a substantial anti-armor capability too, versus Soviet tanks like the T-55. Other variants carried mortars and command and control equipment or served in engineering and recovery roles. Most versions could transport up to 9 infantrymen and an additional 3-person crew. The Rattel saw extensive use during combat operations in Angola and Namibia, and it proved highly effective in mobile warfare. Its combination of speed, firepower, and endurance gave it a tactical edge in the fluid, non-linear battlefields of southern Africa. And one of the most significant contributions was conceptual. It helped define the modern wheeled IFV. NATO nations would not field comparable vehicles like the French VAB or US Stryker until years later. The idea of deploying a lightly armored, highly mobile infantry carrier for asymmetric and rapid response warfare owes much to the Rattel's success. Yet despite the groundbreaking design, the Rattel never saw widespread export. International arms embargoes against apartheid South Africa restricted its market. A few were sent to Morocco and Jordan, and some ended up in private or rebel hands. As of the 2020s, the Rattel has largely been phased out of the frontline service in South Africa, replaced by more modern vehicles like the Badger IFV. A few, though, remain operational with secondary forces, and they're occasionally spotted in African conflict zones, especially in peacekeeping roles. Number 8. The GUS Class Chronoplan. The GUS Class, the GUS Class Chronoplan, also known as the Project 904, was one of the strangest military vehicles ever built by the Soviet Union. A hybrid between a ship and an airplane, designed to skim a few feet above the water surface at high speed, it was part of a broader Soviet fascination with ground effect vehicles, which promised to combine the speed of an aircraft with the payload and range of ships. Developed in the 1970s, the GUS class was part of a secret naval project to test small-scale chronoplans for potential military use. Unlike its larger cousin, the more famous Caspian Sea Monster, the GUS class was small, modular, and lightly armed, intended for rapid patrol, reconnaissance, and possible light strike duties in coastal areas. Now, it operated using wing-in ground effect, or WIG. It was a phenomenon where an aircraft flying very close to the surface experiences increased lift and reduced drag, allowing it to carry heavier loads more efficiently than conventional flight. The class itself was about 24 meters or 79 feet long, and it could carry a small crew. The power plant consisted of twin turbojets mounted above the fuselage, which provided both lift and propulsion. Unlike larger versions, the GUS class couldn't fly at high altitudes. It was effectively glued to the sea surface, usually operating about 1 to 5 meters above the water. It had a modest radar suite and carried small caliber naval weapons like the 30mm cannon or light rocket pods, depending on the configuration. Its mission profiles would have included fast coastal patrols, anti-landing operations, and intercepting enemy small craft at high speed. But what made it notable was its stealthy profile and its speed. Flying just above the water, it produced minimal radar return and could move at over 155 miles an hour, far faster than a comparable naval vessel of its size. However, like the other designs, the GUS Class faced major practical challenges. Its low operational ceiling meant it couldn't navigate high waves or rough seas. Takeoffs and landings were difficult outside calm conditions, and pilots required unique training to manage the unusual vehicle. Maintenance too on the jet engines, which were constantly exposed to saltwater spray, was also problematic. Only a handful of the GUS Class vehicles were ever built, and their use was limited. Most remained as experimental or prototype platforms, though there is some evidence they were field tested in the Baltic Fleet during the 80s. After the fall of the Soviet Union, the project was quietly abandoned, and the surviving craft were scrapped or stored in naval yards. Moving on to number 7, the BAC 111 CC2. Another weirdly named one, the BAC 111 CC2, is perhaps one of the most inconspicuous military aircraft ever operated by the Royal Air Force. At first glance, it kind of looks like a standard civilian jet, and that's by design. This aircraft, a modified version of the British Aircraft Corporation short-haul jetliner, was used primarily for electronic warfare training and VIP transport, performing sensitive military tasks under the radar both literally and figuratively. Originally developed in the 1960s as a commercial jet, the BAC 111 was widely used by airlines across Europe. However, a small number were converted for military purposes. In the RAF's inventory, the aircraft was designated as CC2 and assigned to No. 360 Squadron and later No. 32, the Royal Squadron. While the airframe remained largely the same as the civilian version, the interior and equipment were entirely reconfigured. This one was outfitted with specialized electronic systems, including radar jammers and signal generators. It would fly alongside fighter jets and naval vessels, mimicking the electronic signature of enemy bombers or surveillance craft. It helped air defense crews hone their detection and interception skills. Only a handful of these aircraft were ever converted, and all were eventually retired by the early 2000s, as newer systems and simulation technologies replaced airborne testing. Some were scrapped and others ended up in museums or on static displays. But this plane exemplified the kind of unseen but essential support role that keeps a modern Air Force functioning. While fighter jets and bombers often grab the spotlights, it's aircraft like these that ensure the frontline assets are ready, trained, and calibrated. Number 6. The Skuclass Corvette. The Skuclass Corvette is one of the world's fastest warships, designed for coastal defense, high-speed strikes, and stealth in the complex archipelagos and fjords of Norway. Virtually unknown outside Scandinavia, the Skuld, meaning shield in Norwegian, blends air cushion technology with stealth in a way that no other navy has replicated at scale. Developed in the 1990s and deployed by the Royal Norwegian Navy, the Skuclass is officially classified as a corvette, but it operates more like a hybrid between a missile boat and a fast attack craft. Its most distinctive feature is that surface effect ship hull design, a hybrid catamaran supported by an air cushion between the hulls. This allows it to hover slightly above the water, reducing drag and enabling speeds of over 60 knots, that's 111 kilometers an hour, far exceeding conventional ships. Each vessel measures about 47.5 meters or 156 feet long and displaces around 275 tons. It's built with a carbon fiber reinforced composite hull, and it's extremely lightweight and resistant to corrosion. It also incorporates some stealth geometry, including sloped surfaces and radar-absorbent materials, which drastically reduce its radar cross-section. But despite the small size, it is heavily armed. Its primary weapon is the Königsberg Naval Strike Missile, or NSM, a long-range sea-skimming missile with advanced guidance and stealth. Each Skuld carries 8 NSMs, providing a significant anti-ship capability. It also features a 76mm OTO Melara super rapid gun, as well as a 12.7mm remote-controlled machine gun system and countermeasures for anti-air. The ship's role is pretty clear: defend Norway's coastline, which stretches over 25,000 kilometers, including islands, inlets, and fjords. In this kind of complex environment, conventional large naval vessels are pretty vulnerable, slow to maneuver, and highly visible. The Skuclass, on the other hand, can sprint between islands, ambush larger ships, and disappear into narrow channels. Its high speed and shallow draft allow it to operate in areas that otherwise are inaccessible to heavier vessels. One reason why this class remains obscure, though, is the limited deployment of it. Norway operates the ships exclusively within its territorial waters, and they've not been exported nor widely deployed abroad. Their design also makes them less suitable for blue water naval operations, so they rarely appear in joint exercises with carrier strike groups or large surface fleets. Nevertheless, it represents a highly innovative solution to asymmetric maritime defense. In an era when many nations are rethinking how to defend coastlines, the Skuclass serves as a quiet but highly capable blueprint, fast, hidden, and ready to strike before the enemy even knows it's there. Number 5. The FMA IIA58 Pusara. Continuing the trend of really weird names, the FMA IIA58 Pusara is a military aircraft that most of the world has never heard of, but it played a real role in wartime operations, and it remains one of the most uniquely designed counterinsurgency platforms. Developed in Argentina during the late 1960s and 70s, the Pusara was built specifically for close air support and anti-guerrilla warfare, particularly in rugged, isolated environments. The aircraft's name, Pusara, means fortress in Quechua, a nod to its intended role in the dirty, grinding warfare that typified many South American conflicts at the time. It wasn't conceived to fight enemy jets, but to support troops fighting irregular ground forces. The IA-58 is a twin-turboprop craft with a rugged boom design and high-mounted wings. It features a side-by-side seating for 2 pilots, which is unusual in an attack aircraft, but it allows for better communication in low-altitude combat environments. The fuselage was armored to withstand small arms fire, and the undercarriage is robust enough to operate from unpaved improvised runways, including grass fields and dirt roads. The Pusara can reach speeds of around 500 kilometers an hour, that's about 310 miles an hour, and has a range of about 1,800 kilometers or 1,100 miles. The payload can include internal 20mm cannons, 7.62mm machine guns, and hardpoints for bombs, rockets, or gun pods. This combination made it ideal for low-level attack missions, armed reconnaissance, and convoy protection. The Pusara gained international attention, albeit briefly, during the 1982 Falklands War, when Argentina used the aircraft for close air support against the British forces. Stationed at Goose Green and Pebble Island, Pusaras flew a number of sorties, mostly in low-visibility scenarios. However, they were highly vulnerable to modern British aircraft and air defenses. Despite the losses, though, British forces were impressed enough with the aircraft's performance to capture and ship several surviving Pusaras back to the UK for testing and evaluation. After the Falklands War, the Pusara continued to serve with the Argentine Air Force and other regional forces in Colombia, Uruguay, and Sri Lanka. In Sri Lanka, it was used during the early stages of the Civil War for low-intensity surveillance and strike operations, although it was never mass-produced on a global scale. Several upgrade programs were proposed over the years, including improved avionics, modern engines, and even turbofan variants, but none of them got widespread implementation. As of the 2020s, most Pusaras have been retired or placed in reserve, though a few continue to fly in limited service or as demonstration aircraft. Its legacy is one of pragmatism, built under embargo and economic constraint, and operated in places where few Western aircraft dared to go. Number 4. Fighter FSF1. The Fighter FSF1 is one of the most peculiar ships ever built for the US Navy, and one that never quite found its place in the fleet. Designed and constructed as a high-speed experimental catamaran, the Fighter was meant to test modular mission packages, advanced hull material, and shallow water combat. Developed in the early 2000s by the Office of Naval Research and built by Nichols Brother Boat Builders in Washington State, the Fighter was completed in 2005. It was created to explore the future of littoral or coastal combat with an eye towards what would eventually become the Littoral Combat Ship, or the LCS program. Its unusual aluminum twin hull or swath design gave it both speed and stability, which allowed it to move fast in open water while maintaining low roll and pitch. At 79 meters or 258 feet long, the Fighter could reach speeds in excess of 50 knots, that's about 93 kilometers an hour, and it was powered by a combination of gas turbines and diesel engines. One of the most radical design features of it was its modular mission bay, where containers holding various equipment like mine detection systems, surveillance electronics, or combat gear could be swapped out at port. The concept was to create a floating multi-tool, a ship not specialized in one role, but that could be rapidly reconfigured. Fighter was also designed with a small crew size, under 30, utilizing advanced automation and control systems. It was equipped with a flight deck capable of handling helicopters or UAVs and included stern ramps for deploying boats and diving gear. However, it had no fixed armament and was never intended to serve in a combat capacity. After its launch, it underwent sea trials and technology demonstrations across the Pacific and Gulf coasts. The ship impressed engineers with its performance, but as the LCS program moved forward, many of Seafighter's concepts were either absorbed or abandoned. Eventually, funding dried up and the vessel was taken out of experimental status. By the early 2010s, Seafighter was laid up at a naval base in San Diego, where it remains today, still afloat, technically operational, but inactive. It occasionally appears in naval registers or defense white papers as a technology demonstrator, but few outside naval R&D even know it exists. The experimental modularity and high-speed design were arguably ahead of their time, and its influence can be seen in aspects of modern fast-response multi-mission ships. But it also shows how radical ideas, even when successful, can just drift into obscurity without support or strategic clarity. Number 3. The Type 89 Armored Combat Vehicle. The Type 89 Armored Combat Vehicle, ACV, is one of the most advanced but least discussed tracked infantry fighting vehicles in the world. Developed by Japan's Mitsubishi Heavy Industries and Komatsu in the 1980s and fielded by the Japan Ground Self-Defense Force, the Type 89 was designed to transport troops and defend Japan's home islands in case of invasion. Yet due to Japan's pacifist constitution and its near-zero defense exports, the vehicle remains virtually unknown internationally. Introduced in 1989, the Type 89 was Japan's answer to Soviet-era threats and regional instability. It was intended to replace the older Type 60 armored personnel carriers, which were lightly armored and undergunned. The new vehicle needed to be fast, well-protected, and highly capable of independent combat support. The result was a 20-ton tracked IFV with a crew of 3 and space for 7 infantry. It was powered by a 600-horsepower Mitsubishi diesel engine, giving it a top road speed of about 43 miles an hour. The suspension and weight distribution did allow it to travel over rugged terrain including narrow roads, rivers, and snow-covered areas typical of Japan's interior. The armament is where the Type 89 stands out. It's equipped with a 35mm Oerlikon autocannon mounted in a fully traversable turret, capable of firing high explosive and armor-piercing rounds at 550 rounds per minute. This gives it significant firepower over many other NATO IFVs of the same era. It also carries 2 anti-tank missile launchers capable of destroying enemy armor at a distance. Some secondary weapons include a coaxial 7.62mm machine gun and 6 smoke grenade launchers. Despite all the capability though, the Type 89 was never widely produced. As of the 2020s, only about 120 have been built, serving exclusively in the mechanized infantry divisions there. High production costs coupled with Japan's limited ground force size and budget restrictions meant that the vehicle wasn't adopted at scale. Newer systems like the Wheeled Armored Vehicle or the Type 16 Maneuver Combat Vehicle have begun to shift Japan's focus towards lighter, more mobile platforms, especially in response to threats in the East China Sea and nearby islands. For all of its strength and forward-thinking design, the Type 89 is a hidden gem of armored vehicle engineering. It represents the intersection of Japan's industrial elegance with its cautious military posture. Number 2. The Boraclass Missile Hovercraft. You gotta love hovercrafts. The Boraclass missile hovercraft, known in Russian naval design as Project 1239, is a ground-effect hydrofoil warship that defies traditional categories. It skims over the water like a hovercraft, displaces as much as a corvette, and carries the missile firepower of a small frigate. These strange vessels, only 2 were ever built, are among the largest combat-ready air cushion ships in the world, and they represent nearly a forgotten chapter of post-Soviet naval experimentation. Developed in the late 1980s and early 90s, the Boraclass was designed by the Almaz Central Marine Design Bureau, originally intended for the Soviet Navy to counter U.S. carrier groups. After the USSR collapsed, though, development continued under the Russian Federation, with the first vessel, Bora, commissioned in 1997, and the second, Sanum, in 2000. Both of the ships were assigned to the Black Sea Fleet, where they remained in limited operation status as of the 2020s. At 219 feet long and displacing nearly 1,000 tons, the class is massive for a hovercraft. It uses catamaran hydrofoil configurations combined with lift fans to reduce any drag and increase their speed. It can travel at about 50 knots or 93 kilometers an hour in calm seas, making it one of the fastest heavily armed warships in the world. The firepower this thing has is substantial. Each ship carries 8 P-270 Mosket supersonic anti-ship missiles capable of striking naval targets at range of over 120 kilometers. These are housed in deck-mounted launch canisters, and for air defense and close-range protection, the ship mounts 2 30mm cannons and 2 Strela SAM launchers, and electronic countermeasure systems too. But despite its high speed and heavy weapons, the Boraclass has some limitations. Its seakeeping ability is pretty poor in rough waters, limited operations to calm seas. It's also got high maintenance requirements too, due to the complex propulsion system, which includes multiple diesel and gas turbines. The crew size is large, about 68 personnel, given the amount of onboard systems and redundancy required. Because only 2 ships were built and no foreign navies adopted the class, the Bora remains an anomaly. It doesn't appear in most discussions of modern naval power, and it's often excluded from NATO assessments due to its specialized role. However, both the Bora and the Semom has participated in Russian naval exercises and presence missions in the Black Sea, and occasionally seen in satellite imagery. This missile hovercraft is a mechanical oddity. It's part warship, part hovercraft, part hydrofoil, but it's all packed into a body that looks more like a Star Wars prop than a real vessel. Yet it exists, sails, and stands ready to deliver high-speed missile strikes on coastal or maritime targets. Number 1. The Caspian Sea Monster in the USSR. With officially the best name for a sea vessel ever, the Caspian Sea Monster, officially known as the KM, the Korabel Makat, was the largest and most powerful ground effect vehicle ever built, and perhaps the strangest military transport concept in history. Designed in the 1960s, of course it was in the 60s, by the Soviet Union's Central Hydrofoil Design Bureau under the leadership of visionary engineer Rostislav Alexiev, the KM was part aircraft, part ship, and part test bed for a whole new category of vehicle, the Ekranoplan. Measuring about 302 feet long, longer than a Boeing 747, and with a wingspan of 37 meters, or about 123 feet, the KM was the largest heavier-than aircraft in the world at the time of its construction in 1966. Yet it was never seen in public. It flew, if that's the right word, only a few meters above the water, using an aerodynamic principle known as ground effect. When flying close to the surface, an aircraft experiences some increased lift and reduced drag, and the Soviets realized that this effect could be exploited to carry very heavy payloads at high speeds. What made it so unique was the massive lift-to-drag efficiency, allowing it to hover over the sea at speeds approaching 310 miles an hour, with a takeoff weight estimated at around 540 tons, heavier than any contemporary aircraft. Its power came from 10 turbojet engines, 8 mounted on forward canards for the initial lift, and 2 mounted on the tail for sustained propulsion. These engines allowed the vehicle to, quote-unquote, fly just about 13 to 40 feet above the water surface, way below the altitude of any conventional aircraft. Because of this low-altitude flight, it remained almost invisible on radar, especially at a time when most air defense systems were tuned to detect aircraft flying at standard altitudes. Western intelligence was unaware of its existence until the late 1960s, when CIA spy satellites captured images of it on the Caspian Sea near the naval test facility at Kapysk. Confused by the craft's appearance and lack of wingspan to length ratio typical of aircraft, analysts dubbed it the Caspian Sea Monster, and the nickname stuck around. The legacy of it lives on in smaller Soviet Ekranoplans that followed, including the Lun-class missile Ekranoplan, which carried anti-ship missiles and entered limited service in the late 1980s. But no vehicle has ever matched the scale and audacity of the original one. To this day, no other vehicle has matched the KM's size, speed, or operational envelope in ground effect flight. It stands alone in history as a lost Cold War giant. A ship that flew, an aircraft that sailed, and a machine that blurred the very definition of military mobility.